Hello, all. Welcome to our talk on taking control of streaming data, healthcare data, where we will talk about an implementation we worked on implementing streaming data at an organization called CRISP Shared Services. My name is Chris Mans. I'm a data architect, data engineering consultant at Slalom Consulting, and I'm joined by my friend Andy Hanks.
Yeah, and I'm Andy Hanks. I lead the data analytics team along with a bunch of other smart people at CRISP Shared Services. So let's talk a little bit about what this organization is. Good afternoon, everybody. So we're a nonprofit tech organization that supports a number of health information exchanges. If you don't know what a health information exchange is, there's hope. I'm going to try and hit that on the next slide. We are based in Maryland and remote. And of course, we currently cover 6 states in the United States. So 4 states in the DC metro area, and then somehow we've connected to Alaska and Connecticut as well. So that's what we're up to. So what is a health information exchange? And the answer is, it's a bit like healthcare. It's state by state. If you've seen one state, you've seen one form of healthcare. Now we're past COVID restrictions. Your physician's going to call you and say, which side of the state line are you on right now for this virtual call? It's still very much organized, licensed by state in the United States. So what we support is 6 nonprofit organizations that look to connect healthcare across the state. There's funding through Senate legislation. You can see there. And then the piece that we're finding is that we started with Maryland and some of the local states, and we've added more states, trying to leverage that tech stack and the lessons learned from before. But each state is different. Each of the health information exchanges have a different set of data sources, have different outcomes that they want to achieve right away. They're run by different boards. So it all sounds simple to be the shared technology organization serving all these states, but it's, as you all know, much more complicated. We care a ton about privacy, the third bullet here. Individuals can opt out. We spend a lot of time making sure our data is very tightly secured. And the last point's a little bit what I was talking about. So let's talk about what does CRISP Shared Services do. So at the point of care, that means when a physician or a care coordination person is treating somebody, we can give them information that they don't know about. So we have a portal which they can search a patient's information, and it's already got pre-aggregated their data from all across the state. So if they had a lab test in the farthest end of the state, or they had healthcare in one of the specialist centers, it's all pulled together. That's not necessarily there in the electronic health record that the physician is looking at. So we're filling in the gaps. We're improving care by filling in the gaps and giving them opportunity to go find something. I mean, a good use case is if somebody comes into the ER and either they can't answer questions or they don't have family with them. This is super powerful. Somebody can look it up and say they were in hospital last week. They can look at the CT scan from another organization, and they can look at lab tests, and it gives you a whole jump ahead when you don't know what's going on. Care coordination world, the US healthcare system is amazing, but it has a few gaps, and one of them is when people get discharged, they don't necessarily pick up with continuity of services. So a lot of what we try to do in this public health arena is try to close that gap a little bit. So give advanced warning, and some of that's going to come into our use case today, where when people are discharged, we can actually inform people right away that this is happening. Would be better to be all planned ahead, but sometimes it just isn't planned ahead, and so we're helping organizations that plan that coordination of care later. Bullets 3 and 4 here is really, this is the way we can affect implementation of healthcare in those states. So we're involved in doing analysis around how healthcare is being delivered and be part of informing data-driven legislation changes to make it better. And then the last point here, the public health utility, that's a lot of what we've been able to do with the Databricks data lake environment we've had for the last 3 years. I'll talk a bit more about that later. So we do have a patient portal. We also have a way to embed this data directly inside the electronic health record. So some of the most common healthcare EHRs are Epic, Oracle Cerner, and eClinicalWorks. And so we have a little button up in the corner that says Health Information Exchange name, and you click on that, and up pops a bunch of information that we've pulled together from around the state, and actually across states as well. And that really helps to fill it out. We've actually done some clever things recently where you can either see all the information or all the information not in your current system. So if I'm in a big healthcare system, I've got tons of information about Andy, but I really want to just know, has Andy been going off and getting specialist care in different places so I can fill in this thing? That's what can be provided here. So we jump here to, why are we here talking about streaming? So we get lots of these healthcare messages a day. Anybody know what HL7 is all about? It's Health Level 7 standard. We get lots of them, as you can see. These are lab tests. These are radiology. There's something called admission, discharge, and transfer records, which we actually get a record in some states for everybody who's admitted. So we actually know everybody who's in all of the hospital system. And that was very helpful during COVID to figure out capacity. The next piece we've got is that we started this 3 years ago. No Databricks. I was interested in starting a data warehouse for CRISP. And the smart folks from Slalom came in, and they said, you don't need a data warehouse, you need a data lake. This was before lakehouse was popular. And so we started to build a data lake. We did a talk 2 years ago talking about how we were up in production in 3 weeks and supporting contact tracing for COVID in 6 weeks. So very small team. We jumped in, we did a lot of things very quickly, and it was a great project. So now we've got this mature Azure environment. We can land files, we can process them, and so now we've got this chance to modify an existing solution for doing real-time notifications. So when somebody hits the hospital and their primary care physician can get a notification. Getting that to all work in real time with this volume is good fun. We've got a third-party tool doing that right now. We want to try and bring that in-house. And that's where Chris comes in. So we're taking this Databricks technology, pick up an existing use case, and take it to the next level. Let you jump in, Chris.
Thanks, Andy. Next, we'll dive into the technical solution that we've been working on at CRISP Shared Services. So this is a high-level architecture of the baseline where sources were sending data into a healthcare-specific software called Mirth for health integration, and it was piping out data to a third-party vendor represented by the computer in the bottom, and then CRISP was re-ingesting that in batches nightly into their Databricks environment. So this is the starting place, and this is what we wanted to move CRISP towards. We wanted to actually just take Mirth, which could land the files directly into the data lake, and process those using Auto Loader directly into the Databricks environment, so that we could simplify that process and also do the real-time routing in CRISP internally. So one big piece of this is Auto Loader. So we are using Auto Loader to efficiently ingest files incrementally at scale. We're using it for the fault tolerance, so if a pipeline fails, we can easily pick up where it left off using checkpoints. We're using it for near real-time processing of these files as they land. So there's a queue in Azure Storage where it records all the files that have been created, and we just read from the queue. And then this abstracts complexity for developers and simplifies the streaming ingestion process. This is just a quick code snippet to demonstrate a simple ingestion. We're reading from the cloud files the autoloader format. We're declaring a checkpoint in the options below. We're specifying a trigger type, which comes from a configuration file, and we're starting the query. So these pipelines are metadata driven, so we have our configuration separate from the code, and that enables reusability of notebooks. So we reuse our autoloader ingestion notebooks for multiple different types, like Andy mentioned HL7 v2, HL7 v3. We can reuse that notebook for these different use cases. by using the configuration separate from code. So this really speeds up adding new sources, adding new use cases to the data pipelines. It also makes it easier to update configuration, helps document the configuration. We can see it all in one place, and it really just speeds up the process of adding new data pipelines and new sources. This is a simple example of one of our metadata examples. It's a JSON format, and we just have some key value pairs where we document the landing path of the file type, and the trigger type. Another important piece here is that we were able to quickly switch between the trigger types. So in development, we used batch processing just to save costs while we were developing these pipelines, but then we were able to quickly switch to streaming when we were ready to go live. Next up, I want to talk a little bit about parsing HL7 messages. This was a big part of our project. So we take these healthcare messages, HL7 messages. Primarily, these are HL7 v2 in CRISP, although we do work with HL7 v3 and other standards. So we created custom classes and methods and functions to parse these into a complex data type in Spark that could be queryable. We also use the official HL7 schema as metadata to inform parsing to help us, because sources often send data that is not standardized, so they frequently will they should be sending, like, for instance, escape characters, but they don't send the correct escape characters, and if we parsed it without using the HL7 schema, we would parse fields into the wrong location. So we're using the HL7 schema to determine if something is like a simple data type, so we don't break it up, even if we encounter what would be a separator character. And at the end of this, we store the data in CRISP's data lakehouse and Delta tables, so that CRISP can use this for all sorts of use cases downstream. So at the bottom, you just see this is a quick code snippet where we're just applying. We apply channel logic based on different sources. So CRISP has different sources, different healthcare institutions, other HIEs that send data, and we do provide some standardization logic. So this is in the second layer. If you want to think about Databricks medallion architecture, more like the silver layer. Next up, we have an example of the HL7 v2. So at the top, this is a raw message that comes in. It's a delimited message, but it's not a simple delimited message. Each line represents a different segment, and then segments are broken up into fields and subfields. And on top of that, some segments can have repetitions and fields can have repetitions. So it's quite complex. So what we do is we parse it into the complex data type you see on the bottom left. And this so that we can query different segments, fields, repetitions, as needed for different use cases. And then on the right, you can see where we actually pull the data out and flatten the table. So in this case, we have a fake HL7 from Adam Everyman. This represents an admission, and we're able to pull that information out. And we can see the event type and the message type and the patient's name.
Every time you have a lab test, one of these messages gets moved around somewhere in the US.
So next up, we're going to talk about addressing a lack of standardization in healthcare data. So as we just mentioned, sources, there is a recommendation with the HL7 specification, but not all sources follow the recommendation. So we do apply standardization to make the data usable across sources. We also do things like determine a patient's source and MRN, which is a medical record number. So we can do things like enable patient matching across sources. So we standardize patient demographics, patient class, and timestamps. And we convert values that are coded into meaningful values. So in this case, you can see we have two examples where one source is sending us admissions that are based on an alphabetical character, and the other one is sending admissions based on a numeric character. And we convert those into usable admission types downstream. A big piece of this that's been really helpful in the Databricks environment is data validation with Delta Live tables. So we can set data quality expectations in Delta Live tables. We can use those, easily define them as decorators. Those expectations then become reusable and portable, so we can use them across use cases. So if we have some rules around, say, a patient's date of birth that we try to weed out invalid date of birth, we can use that on our HL7v2 use case, also on our HL7v3 use case, and we can just take that same rule and use it in multiple places. This also allows us to filter downstream processes. So like the patient match API, for instance, certain APIs downstream, like patient match, require certain data types. So we flag data that doesn't meet those requirements, so we can filter that out so it doesn't fail downstream APIs and things of that nature. And Delta Live tables also provides visibility into data quality statistics as we're processing these expectations. So this is a brief example of the expectations, just some simple rules, validating that a date of birth is greater than 1900 and valid social security length. But I just want to show that they're easy to implement, they're easy to define and to add in the DLT decorators in the second image. And then in this case, we're not actually filtering these records, we're flagging them so that downstream processes can filter them out. One other piece of this is we're actually creating a feedback loop for those providers so that we can tell them about their data quality and they can improve data quality in the future. Next, I'm going to talk about maintaining scalability. So we're already processing over 1 billion messages per day. This is admissions, discharges, labs, radiology, like Andy mentioned. And they come in at different rates throughout the day. During business hours, the volumes are much higher. Using Delta Live tables, we've used the enhanced auto-scaling to really control our compute costs, but scale up when we see spikes in delivery of files. So this has been really helpful in maintaining costs, but also maintaining scalability as files come in. Last but not least, I want to talk about sharing with Databricks SQL Warehouse. We share internally with our teams, different analysts, but also other teams that use this data in their applications. And the SQL Data Warehouse lets these teams connect using the language of their choice. So in some instances, they're using JavaScript to connect and pull a batch of data into their application and process it for different things, and then send out notifications based on the data they processed. This allows them to leverage that distributed compute in Databricks. And we can also monitor the query history and details in the UI. So we can identify bottlenecks in their queries, long-running queries, and it's just been really tremendously helpful for sharing data securely throughout the organization. And we can permission different teams for different data sets and different tables that they need access to. Lastly, let's talk about the impact of streaming. So as we mentioned today, CRISP is currently receiving over 1 million messages per day, 100K messages per hour during business hours and growing. CRISP is constantly adding new sources, new states, and new providers into the streaming process. And as soon as they add a new provider, those messages get streamed into the data lake and picked up by Auto Loader, and they just get fed right into this process. There's no additional configuration that's required unless we want to do some of that standardization and other things we mentioned. And I'll hand it off to Andy to talk more about the impact of streaming at CRISP.
Yeah, so great, Chris. So I think the amazing thing is that we got a good use case for starting streaming. We've gotten it up and running. Definitely encourage you to look at streaming. It's very doable. But what we've been able to do is build something that can run at speed. I think Chris mentioned somewhere that we're landing these messages within 45 seconds, often much faster than that. They're all the way through into a curated Delta layer. So we're able to use that in near real-time calculations. Scalability is, this is pretty cool. When we said, should we use Databricks streaming, we did some benchmarking. And so we benchmarked what it would take for us to do the entire day's worth of messages, and it came out to about 20 minutes on a fairly small cluster. So this is very powerful technology. We're getting into more complicated use cases above this. So this presentation's about handling the incoming messages. Now we're starting to do some real-time streaming that combines those messages with some lists of patients and actually coming up with answers in real time as well. The other thing I talk about scalability, and there's been a great partnership with Slalom. They have helped us. They'll blaze the trail, help us with the technology implementation, but they've helped us build a team. So we only started 3 years ago. Now we have a fairly robust set of data engineers, data analysts, and that's key, right? Because as you move forwards, it's really hard to move that technology back in-house as you take those leap ahead. So this has been a great partnership. So Chris is taking us to places. We're talking with Databricks. They're giving us advice on how to best structure this. And then we're able to implement that through into our team. So that's huge. And at this point, we have had no concerns about scalability. And I say that because if you go into this thinking about it, I remember when we first thought about it, I'm like, why would we go down this path when we've got a perfectly good third-party tool? But we spent our time, we did our due diligence. Chris said, yeah, we can do it in 20 minutes. And I'm like, prove that to me, show me that. And so we've been running streaming now for several months in sort of a pre-production stage, about half of our volume, and it's handling it beautifully. It's not breaking. When we had to take it down, it's come right up. We found some interesting things where if we have a cloud outage, some of the streaming takes a bit longer to pick back up again, and I think that's just part of the nature of the technology. And again, we're talking with Databricks about how we can best do that so we can run an operational system, right? Because it's fine to have a system that runs, but we want to have a fully operational system. Tons of flexibility here. Clearly, running things metadata, lots of JSON config enables us to scale rapidly. It enables us to grab more from that source data. I think we've tended to handle just a subset of the data coming in. Now we can go further and say, I've got a use case, I want to hit this other piece of data. Data quality is my dream, is we allow our senders, so we get data from hundreds of sources, right? And different shops with different capabilities. And in theory, there's a spec, and everybody should send it in perfectly according to the spec, and it doesn't really work like that. So my dream is that we have something that starts to give them real-time feedback. We do a working session, they send us 10,000 messages, we process those 10,000 messages in a few minutes. We give them a dashboard that says, you hit these data quality numbers, you go fix your feed. Instead of, and you're all nodding your heads because you know how this works, right? They send it in, you look at it for a couple of days, you send them feedback back, they say, how about a meeting in 4 weeks? And we never quite get on that cycle, right? So trying to get that feedback loop near real time, I think is a real promise here. We haven't done it yet, but I actually think we're very close. We're starting to build those streaming Power BI dashboards that start to give that feedback. Chris talked about using SQL Warehouse. We found some nice places to use that. We probably have, we've actually shared across our organization. We have 60 or 70 people now using Databricks notebooks and doing data analysis across our organization. And it's starting to sort of infect, and people are going, okay, so you now actually have all the data in the middle. I actually am interested in this. Instead of looking at App Insights logs and different things, people are focusing and saying, it's now there. And then in terms of simplicity, clearly, this is a major sort of move that we're taking a system that was third party, was integrated into our infrastructure, and we're bringing in. It's a big lift for a small organization like us, which we tend to do fast, innovative, deliberative things, but it's been really good. Anything I missed, Chris?
No, that's great.